Okay, let us see the first question. The density of 96% H2SO4 is 1.87 grams per milliliter. Calculate the molarity of the solution. So what we have to do here is first 96% means what is that means is 96 grams dissolved in 100 grams of water. Okay. And then from that 96 grams, we will find the number of moles. So 96 divided by molar mass, which is going to be, when you do that one, you will get 98.072. That equals 0.97887. And then that is the number of moles, because we know the molarity equal number of moles over volume in liters. And now we will find the volume. To find the volume, we know the density is given 1.87 grams per milliliter. That means it is in 100 grams of water, right? So density equal that mass divided by volume in liters. That is what we are going to find. So that means volume in liters, rearrange that one. So 100 divided by 1.87, that is equals 53.4759, right? And that is in milliliters. So to convert it into liters, we have to divide that one with 1,000. That equals 0.053 liters. Alright, after that we just substitute in molarity equal number of moles divided by volume. Number of moles is 0.97887 and the volume is 0.053. So the answer is going to be 18.3. Okay. Okay, the next question is, what is the freezing point of 0.2 molal BaNO3 twice? The freezing point depression constant for water is 1.86 degree C/m. So what we have to do, we just use the formula delta TF, because that's the freezing point change, that equal number of ions produced by BaNO3 twice times molality times we know that is Kf. Kf is given. I we know 1 barium ion and 2 NO3 minus ions. So I have total 3 of them. So this is 2, this is 1. So total 3 ions, and molality is given as 0.2 and Kf is given as 1.86. So when you multiply that one, we will get 1.116 degrees Celsius, and then this is change in TF, that is change in temperature. So what is the freezing point is that is the depression in freezing point, the one we calculated. So freezing point will be 0, that is the freezing point of water, minus 1.116, that equal negative 1.116. When you round it, you can get that one as negative 1.12. So the answer is C. For the next question, which of the following will have the highest boiling point? To find the highest boiling point, what we have to do is, remember when you take some water and when you add some solute in it, the boiling point will elevation in boiling point. The boiling point will elevate when you add some solute in it, and that depends on how many ions it's going to produce. So what we will do, from the given answer choices, we will find which one will produce more ions. So all are 0.1 molar, as you noticed here, and in this case this is not an ionic compound, so it's going to produce only one, there is no ion, only one particles, and in this case 2 sodium ion and 1 sulfate ion, so we will have 3 ions, 1 potassium and 1 nitrate, so we will have 2 ions, 1 aluminum ion and 3 chloride ions, so total 4 ions will be produced here. 4 particles will it dissolve in that water, and it will elevate the boiling point. So boiling point will highest in the case of aluminum chloride because the number of ions are the greatest in the given answer choices. So the answer is E. Next question is, consider the reaction 2A plus 3B gives 4C plus 5D. If the rate of formation of C is 5.00 m/s, what will be the rate of formation of D? So we are just comparing the stoichiometry here. So in this case, we know that 4C and 5D is forming. So if we have formation of 5C, so 5C, how much D will form? We can just cross multiply, or we can just go with the stoichiometry the other way around. So it will be 25 divided by 4, which equals 6.25. The rate law for a reaction A plus B gives product is rate equal K concentration of A to the power 2. What will be the effect on the reaction rate if the concentration of B is doubled but the concentration of A is unchanged? So what we have to look here is, in the rate law expression we don't have B. So the rate depends only on the concentration of A, and it says concentration of A is unchanged. So that means it is not going to make any difference whatever you do with the B. So that means rate is going to be unchanged. Answer is A. Okay, next question. The chemical reaction 5Br minus plus BrO3 minus plus 6H plus gives 2Br2 plus 3H2O has the rate law rate equal K concentration Br minus, concentration BrO3 minus, concentration H plus to the power 2. What is the overall order of the reaction? To find the overall order, we will just add all the order from the rate expression. So here 1, this is 1, this is 2. So 1 plus 2 equal 4. So the answer is E. Next question is, the half-life of a first order reaction A gives product is 2 minutes when the initial concentration of A is 1 molar. What will be the half-life of this reaction when the initial concentration of A is 0.5 molar? So one point we have to remember is that for the first order reaction, the half-life is going to be constant. Doesn't matter when the concentration changes. Okay, so the half-life given is 2 minutes, so that's going to be same for this reaction. So the answer will be C. Next question is, at 184 degrees Celsius, the equilibrium constant K is 1.48 times 10 to the power 4 for the reaction 2NO plus O2 gives 2NO2. Calculate the value of K for the following reaction. 4NO2 gives 4NO plus 2O2. So what we have to do here is we have to look at the equation and see what are the changes in the required equation. So the given equation is 2NO plus O2 gives 2NO2, whereas the required equation is the reversed. That is, NO2 is the reactant now, NO2 was the product, and then the reactants in the original equation are now the product. So that means the equation is reversed. And another change I can notice is the coefficients 2, 1 and 2 change to 4, 4 and 2. That means this equation, the original equation, is multiplied by 2. So we should know the rule what happened to the K value when some equation is multiplied by a number. So K value will be raised to the power that number. In this case it will be K to the power 2. And when the equation is reversed, what happens is the K value will be the reciprocal. Okay, so in this case we can say that 1 over K to the power 2. So we have the K value 1.48 times 10 to the power 4. So we have to raise that one to the 2, and we have to take the reciprocal to match with the given equation and the required equation. So that equals, when you plug it in the calculator, we can see 1 over 1.48 times 1.48, that is the square of that one will be 2.19 times 4 times 2 will be 8, so 10 to the power 8. That equal, I'm just isolating that exponent, 2.19 times, I'm taking that exponent to the numerator, then it will be negative 8 So 1 over 2.9 will be 0.456 times 10 to the power negative 8. When you move the decimal, you will get 4.56 times 10 to the power negative 9. That's the answer. So the answer is C. Okay, for the next question, for which of the following reactions are the numerical values for Kp and K are same? So Kp equal Kc RT to the power change in number of moles of gas particles. So if this delta N equals 0 means we can say that Kp equal Kc because the whole term will turn to 1. Correct. So let us see that one. So in this case we have 2 moles here, 1 mole here, 2 moles here. So product minus reactant, so that will be negative 1. So in this case 1, 1 and 2. So 2 minus 2 will be 0. And in this case 1 plus 1 and this one will be 2, so that means 2 minus 2 equal 0. So which of the following reactions are the numerical values of Kp and K are same is, I can say that 2 and 3. So the answer will be E. Next question. Next question is, which of the following equilibria will be affected by change in container volume? Le Chatelier principle, right? So we can see that the number of moles for the first one here on the reactant side 2 plus 1 3, and on the product side it is 2. So that means 3 moles changing to 2 moles. That means volume is the number of moles are going down. Okay, so what happened when the container volume, which of the following affected by change in, so it will be affected by change in volume because the number of moles are different on product side and the reactant side. So this one will be 1 plus 1 2, and this is 2, so 2 moles and 2 moles. So no effect in this case because the volume, number of moles are not changing. So 1 plus 1 for the third one, this is also 2 moles, gives 2 moles. So no change in the number of moles, so no change, or it is not affected by changing the volume of the container. So the answer is E, 1 only. Next question is, consider the equilibrium 2NH3 gives N2 plus 3H2, delta H is positive 46.1 at 298 Kelvin. Which one of the following disturbances will cause the equilibrium to shift to the right? So this is, since it is positive value, this is an endothermic reaction. Endothermic means heat should be on this side. Okay, so then removing ammonia. So they are asking right shift, so we need this shift. Okay, so if you are removing something from this side, the equilibrium will shift to this side, correct, if you do that. And decreasing the container volume, so how many moles are here? We have 2 moles here and 3 plus 1 4 moles here. If you are decreasing again, we will have to this side. Container volume decreasing means the pressure is increasing. When the pressure increases, it will have a tendency to go to the less number of moles, correct? Okay, so again it will go to the left shift, and then so this is not the answer, this is not the answer. Adding a catalyst will not have any effect. Increasing the temperature, so when you increase something on this side, increasing the temperature, what will happen? The system will have a tendency to go this way. That is exactly what the question is asking for. So the answer is D. And the last one is increasing the partial pressure of nitrogen. That means if you are increasing the pressure here, what will happen? It will have a tendency to go to the other side. If you do this one, it will go this way. Okay, so the answer is D. For this question, which of the following pairs of species is not a conjugate acid-base pair? Conjugate acid means by removing hydrogen, you will get a conjugate acid. Okay, so by removing hydrogen, and by adding hydrogen, you will get conjugate base. So that means Ha plus B If this is the acid, this is the base, A minus is the conjugate base, that means we are removing the hydrogen, and HB, we are adding that hydrogen, so this is going to be conjugate acid. So we have to pick either this way or we have to pick these two for the conjugate acid base pair. Okay, so in this case we can see that we have hydrogen here, it is removed and it is forming O2 minus. So that is a conjugate acid base pair. In this case H2S and S negative 2, it is two-step process. So we cannot say that that is a conjugate acid base pair because two hydrogen removed. And in this case we can see one hydrogen removed and we have HCO3 minus. So that's a conjugate acid base pair. In this case also this one hydrogen removed and we got this one. One hydrogen removed and we got NO2 minus. All these are conjugate acid base pair, whereas this one is not, and they are asking which of the following species is not conjugate acid base pair. And now calculation of pH. What is the pH of 0.023 molar HCN? So first step, and Ka value is also given. So the first step when you calculate a pH is, first step is to identify what is given, whether it is strong acid, strong base, weak acid, weak base, like that, or is it a buffer, like that. So in this case I know this is a weak acid, right? So for weak acid, we know in general we can write Ka is X square divided by concentration of the weak acid. Okay, we can make a rise table, but this is a shortcut. Okay, so Ka is 4.9 times 10 to the power negative 10, and X square will give me the concentration of hydrogen ion. So that means X is nothing but concentration of the hydrogen ion, and concentration of the acid is 0.023. So we can calculate that one by plugging in the calculator. We can see that 4.9, I'm just trying to isolate the x first before plugging into the calculator, that equal x square, and then take square root on both sides to get the x value, and then we are going to get 3.357 times 10 to the power negative 6 is our x value. And then that is nothing but our hydrogen ion concentration. After getting the hydrogen ion concentration, pH equal negative log hydrogen ion concentration is going to be 3.357 times 10 to the power negative 6, that equal 5.47. That's going to be our pH, which is answer D. Okay, this question is, which of the following reaction is associated with the definition of Kb? Kb is nothing but base dissociation constant. So that means we have to look for a base. Base means we know that should contain hydroxide ion. So if it is producing hydroxide ion, that's going to be basic. So I can see that the first one is hydroxide ion production. So that is base or basic, right? Basic solution. And then in this case, if you want to explain the rest of it, you can see that this is a weak acid, HCN. It is starting with a hydrogen. So that's a weak acid and it is producing hydronium ion. If it is producing hydronium ion, that is acidic. So here is hydrogen ion, which is similar to hydronium ion, right? So this is also going to be acidic. And in this case, we can see that HCN minus plus F minus CN minus plus HF, this is HF is a weak acid. So this is also acidic. So the answer is A. Okay, this question is also pH calculation, and now I have identified which compound it is asking. So first I will see the compound, that is BaOH twice. That means that is a base, and then I have to decide whether it is strong or weak. It is a strong base, and we can see that the concentration is given, and the only thing is we have two hydroxide ion. That means when you put barium hydroxide in water, it will change to barium ions and two hydroxide ions. So our concentration of barium hydroxide will give us double hydroxide ion concentration because it is 2. Okay, and then what we will do, since it is a base, we will first find the POH, that equal negative log hydrogen ion concentration, and then pH we will calculate by subtracting that pH 14 minus POH. Okay, so what POH is going to be, that negative log POH will be negative log 0.04. When you plug it in the calculator, it will be 1.398, and so pH equal 14 minus 1.398, that equal 12.60. So our answer is C. Okay, this question is asking us the aqueous solutions of which of the following salt will have a pH less than 7. pH less than 7 means it should be acidic. So we have salts here. So we will divide this one into basic, acidic and neutral salt. How can we decide is potassium, that is the first part, NO2 minus, that's the second part. So K plus and NO2 minus. I am splitting that one into two, and the first part I am adding OH because this part is coming from the base. So I am adding OH, that is the base, and to the right part I am adding hydrogen in front of it. That means it is coming from the acid. So KOH and HNO2. What I will do next is I will see whether it is strong or weak. This is the strong base and this is the weak acid. Always strong wins. So this, the first salt is going to be basic salt. And the second one is same way we can explain KOH and HNO3. HNO3 is strong. So this is strong base and strong acid. So that's going to be neutral. So the pH is going to be 7. For the basic, pH is going to be above 7. And this one is going to be NH4OH and HNO3. NH4OH is weak base. HNO3 is a strong acid. So if it is strong acid, the pH is, this one is an acidic salt. So for the acidic salt, the pH is less than 7. And we don't have to go with this one. We don't have to go with this one now because we already got the salt, acidic salt, which is less than 7. So that's the answer. So C. Okay, this question is pick the weakest of the following oxy acids. So when the number of oxygen atom increases, that means it is electronegative. So the strength of the acid will increase. So we can see that here we have 3 oxygen, 4 oxygen, 4 oxygen, 4 oxygen and 3 oxygen. So just by comparing the number of oxygen, we can eliminate B, C and D because they are going to be stronger. They are asking the weakest one. And now from choices A and E, we can pick one of them based on the electronegativity of the next element other than oxygen, which is sulfur here, selenium here. If you look in the periodic table, 16th group, sulfur is above selenium and electronegativity decreased down the group. So which one is going to be the weakest is the one with the lowest electronegativity. So E is the right answer because selenium has the lowest electronegativity. So that means it's not going to pull the electron towards it, and that means the hydrogen is not going to leave as easily as in the element with a more electronegativity. In this case it is sulfur. Sulfur and oxygen is going to pull the electron towards it because both are more electronegative, and the hydrogen can leave as hydrogen ion. So that is going to be stronger acid compared to this one and this A and E. This is going to be stronger acid and this is going to be weaker. Okay. Okay, so this question is which one of the following combinations cannot function as a buffer solution? So you should know a buffer solution means it should be a combination of weak acid and its salt or a weak base and its salt. Okay, so here NH3 is a weak base and its salt is here. So it can be an answer. But let me check the other one. HF is a weak acid and this is it's salt. So it can be a buffer. First one can be a buffer, second one can be a buffer, and the third one is a strong acid which is not under our definition now. So this is not a buffer. It cannot act as a buffer. And now the next one is a weak acid, and it's salt. So it is a buffer. This is a buffer. This is a buffer. HN, HNO2 is a weak acid and NaNO2 is its salt. So this can be acting as a, this can also act as a buffer. So the answer is going to be C, because they are asking which cannot function as a buffer. Next question is pH calculation of a buffer. So what are the things given here? They gave 0.25 moles of acetic acid, pKa value is given, and 0.4 moles of sodium acetate. It's already given buffer here, and it makes 1.8 liters of solution. So what is the formula for calculating the pH for a buffer? pH equal pKa plus log concentration of conjugate base divided by concentration of weak acid. Okay, so pKa is given as 4.74 plus log conjugate base is sodium acetate here, so that is 0.4 moles. Okay, so since it is moles, we have to convert it into molarity divided by 1.8 divided by 0.25 divided by 1.8. So let's go ahead and calculate that. Since both are divided by 1.8, it's not going to make difference. 1.8 and 1.8 will cancel, and that equals, we will get the pH, we will get 4.74, and when you take the log of log 0.4 divided by 0.25 equal 4.74 plus, that is 4.74 plus log 1.6. So that equal 4.74 log 1.6 is 0.20, that equal 4.94. So the answer is E. Next question is the KSP question. What is the KSP expression for the magnesium phosphate? So what can be Mg3PO4 twice will give you 3 magnesium ions, and I will have 2 phosphate ions, right? So that means Mg2 plus to the power 3 PO4 negative 3 to the power 2. So which is the right answer here is D, isn't it? Yeah. Okay, so let's see this question. The solubility of silver oxalate Ag2C2O4 in pure water is 2.06 times 10 to the power negative 4 moles per liter. Calculate the value of KSP for silver oxalate from this data. So what we have to know here is they gave us the solubility, that means X is given, molar solubility is given, X equal 2.06 times 10 to the power negative 4. And now we should know how many ions it is going to produce in the solution. So that means it will give us 2 Ag ions and 1 oxalate ion, correct? Okay, so 1 oxalate ion and 2 Ag ions. So here we know that is going to be 2x, this is going to be x. So that coefficient 2 goes in front of the x as well as to the power x when you write that one KSP expression. KSP expression 2x to the 2x square times x, that means 4x square times x, that's going to be 4x cubed. So that is our KSP expression for this one. So then I will just substitute that x value. 4 times x is 2.06 times 10 to the power negative 4 to the power 3. So 4 times, you can either enter directly to the calculator or split it down, times 2.06 times 2.06, and then 10 to the power 4 times 3 is 12, 10 to the power negative 12, and when you plug it in the calculator you can, okay, so you will get the answer 3.49 times 10 to the power negative 11 when you solve this. For which of the following processes would delta S not be expected to be most positive? So most positive means more entropy. More entropy means more randomness, more gaseous particles on the right side we are looking for. So this 1 plus 2 and this is 2, that is less number of particles on the right side, so not, that's negative entropy, and this 1 gives you 2 gas and gas, so we have more positive entropy here, entropy is going up. So since it is most, I have to check further. So this one particle changing to solid, so entropy is less here, 2 solid, and here 2 gas, 1 gas, so total 3 plus 4, 7, of course, 7 gaseous particles on the right, it will have more entropy, positive entropy, right? And the next one, I don't think I have to check, 1 plus 1, 2 gives you solid, so entropy is less. So the answer is D. For the next question, using the standard entropy values as given here, hydrogen, iodine and Hi, the standard entropy values are given. Calculate the standard entropy change for the reaction H2 plus I2 gives 2Hi. So what we have to do, products minus reactant. So for the products, so that means delta S0 equals sigma of delta S0 of products minus sigma of delta S0 of reactants. So for the product I have 2Hi, so Hi is here, so 2 times 206.5, all are in joules, so I don't have to worry about the unit, minus I have 2 reactants, hydrogen 130, it is balanced already, so 0.6 plus iodine 116.12, so you will have those two, and then when you add them up and subtract, you can see the delta S value is going to be 166.28 joules, and the answer is it going to be positive or negative? It's going to be positive value, so answer is going to be D. Okay, in this question, for a reaction, if delta G naught equals 0, then which one of the following is the matching one? So delta G naught equals 0 means the system is at equilibrium. Okay, so I hope you remember keg 100. So that means less than 0, greater than 0, greater than 1. And these conditions, we say that the system is thermodynamically favorable. So if K equal 1, E0 value equals 0, and G0 value equals 0, we say that these are at equilibrium. So which one is matching from the given answer choices? It is A is matching with that one. Okay, so A is the right answer. For this question, I would say we can omit this question as well because we haven't done this type of question. Delta G, for this question we have to use the formula delta G equal delta G naught plus RT log Q, and we can calculate the Q from the given atmospheric pressure here, so that means 4C, so delta G 77.8 plus R is in joules and this is in kilojoules. I am going to convert that one into 0.008314, and the temperature is 298, and log Q will be C to the power 4, that means C is 2.5 to the power 4 divided by, and I have B 2 times, so the B is 4, so 4 to the power 2 times A is 2 and 2. So when you solve this one, you will get 78.3, but don't go for this one because we did not use this formula in the class. Okay. For this question, the standard reduction potential for the following half cell reactions are given. So what we have to do is we can see that what is the E zeros for this galvanic cell. So E0 only they are asking. So what we have to do, which one is oxidation, which one is reduction. So this is negative value, so this is going to be oxidizing, and that means I had to flip the value 0.73 and then just add them up 1.09. So it will be 1.82. D is the right answer. For this question, in the cell shown, which reaction occurs at cathode? And they have given the cell notation. We know cell notation, anode will come first and then cathode will come second, right? So oxidation here and reduction here, red cat, right? Okay, so the reduction will be Ag ion will changing to Ag atom. So we can say that A is the right answer. Okay, in this question, consider the following standard reduction potential in acidic solution, and they are asking the strongest oxidizing agent. Oxidizing agent means that is getting reduced. So which one will be reduced here? The highest reduction potential will get reduced. So this is the reduction. So we can see that one MnO4 minus is the strongest oxidizing agent. Okay, this question is asking us to calculate delta G naught at 298 Kelvin for the following reaction. So the reaction given is balanced. E0 value is given. So delta G and E0 we can connect through the formula delta G naught equal knife, negative knife, right? And then substitute negative 2 times 96,485 times 0.13, that equal 25086.1 joules. We can convert that one into kilojoules, divide by 1000, that equal 25 kilojoules. So the answer is, yeah, of course, negative. So the answer is E. Okay, now this question is, what mass in grams of copper will be deposited from a solution of Cu2 plus by a current of 2.5 ampere in 2 hours? So I will start with the equation. So that is Cu2 plus 2 electron gives you C. That is going to be our reduction reaction, and it is asking for the mass. So that means how much copper it will deposit, and they have given. So the first step is I will calculate Q equal IT. Current is 2.5 times time is 2 hours. I have to convert that one into seconds. So that is Q equal IT I am using, and then that will give me, when you plug it in the calculator, this much charge coulombs. The second step is I will find this many coulombs will equals how many electrons. So I know 96,485 coulomb is 1 mole of electron. Okay, so then 18,000 coulomb is how many moles of electron. So when I cross multiply and divide, so multiply these two and divide by the other number, that means 18,000 divided by 96,485 will give me 0.1865 moles of electrons. Okay, and the third step is I know from the equation 2 moles gives me the molar mass of copper, 1 mole of copper. So what's the molar mass of copper? I will see from the periodic table. So 2 moles of electron will give me the molar mass of copper is 63.5 grams. Okay, so I have how many moles of electron? 0.1865 moles of electron. How many grams will produce? So I know that is, just multiply these two and divide by this number, right? So that means 0.1865 times 63.5 divided by, okay, so that divided by 2 will give me 5.9 grams. So the answer is E. So this question is telling a radioisotope decays to give. That means on the product side I'll have Pb2O8 and an alpha particle is He24. So I have to have, when you add these two, I should have 2, 1, 2. So I should have polonium. C is the right answer. Okay, this one C14 undergoes beta decay to form what nucleus? So let's see. C14, and from periodic table I know that the atomic number is 6. So beta decay is E -1 and I have a new element formed at the bottom side 6 and -1, so I should have here 7 to make it equal. 7 minus 1 is 6, and the new element which one is 7 from the periodic table, I see that that is nitrogen, and 14, and this is 0, so I should have 14 here. So 14 plus 0 will give me 14. So the answer should be in 14.